Gonna adjust that a little bit. All right, so we're gonna go through this first example quick, and like we just talked about, we're gonna make sure that we get this into row echelon form so that we can do a little more substituting and actually solve for the variables. So if we remember right, when we're working with this to try to get it down into row echelon form, we have three methods for solving the system by elimination, and those three methods are going to be to switch any two equations, to scale an equation, and to add or subtract two equations. So we are given this system of equation, and in order to find this, like I said, we're going to move it over to row echelon form. So that's going to be what this video is about. And so my first step is going to be, I'm thinking it's going to be to add this vector to this vector, because the goal is to eliminate as many variables as possible. So we're going to add this one to eliminate the x. So I'm going to draw an arrow there and do plus R1, R for row. So this plus this is going to give us our new middle vector. So we're adding this vector to this vector, and this vector is going to stay the same, okay? So when we add these two together, our new system is going to be x minus 2y plus 3z equals 9. And then now that we've added this to here, we've got a positive y, no x, because x minus x is 0. And then we also are left with 8z equals 5. Right? Oh wait, no. Not 8z. Just 3z. So what I did there, I accidentally added that one to that one, but we are in this row and there's no z value there. So 3z plus 0z is 3z, and then the bottom one stays the same. Oops. That's pretty poor. All right. So this is our new system of equations, and we're just going to keep rolling. That's the thing with these, is that you might have done one step, but this is definitely not row echelon form, and this definitely does not make substitution and solving for variables any easier. So we're going to roll through this a little more, and we really want to get rid of the x variable here, because like I had in our example, we had the x, and then we didn't have any x's, and then we didn't have any x's or y's. So now we're going to try to get rid of this x. To get rid of this x, I think that we're going to have to subtract 2x. And so if you think about where we can get 2x, or where we can subtract 2x from, given our three methods of solving by elimination, the only place that we can pull 2x's from is going to be this top equation here. So what I'm going to do in this step is I'm going to add, and remember that we can scale an equation. So that's what we're going to do. We're going to scale this equation so that we have enough x's to cancel these out. And so that would be negative 2 times R1. And we're going to add that whole thing to this row. And so I'm going to do that on a step lower. I'm just going to make sure that you'll be able to see it. I'm going to tilt the camera down a little more. So I'll be doing that real quick right here. So we still have our top equation that hasn't changed at all. And then we've got our middle equation that is the same as last step. And now we're adding 2r1 to this whole equation, or negative 2r1. So that's going to end up being negative 2x. That's going to end up being 4y. And this is going to end up being negative 6z. And so now we're going to add these to the bottom equation here. So negative 2x plus 2x is going to be 0x. 4y minus 5y is going to be negative y. And then negative 6z plus 5z is going to be negative z. And then 9, we're going to have to multiply by negative 2 as well to get 18, or negative 18. We're going to add that to 17, and we're just going to get negative 1. So, we made another step, and we're pretty close. We can see that we don't have any x's here, we don't have any x's here, right? And so we just got to get rid of one of these two z's. So what we're going to do now is we're going to look at how we are going to eliminate this y, and this should be pretty easy to see, and I'm going to do this up there, but we're just going to add R2 to R3. So I'm going to do plus R2 there, and then we'll bring that up here to our row echelon form section. So we have our original equation still set up there, x minus 2y plus 3z equals 9. And then we have our second one that hasn't changed since the first step. And then we have our last one, which we have just added row 2 to. So we are left with 2z equals 4. And so once we have that, we can very easily solve for z. And this is actually how you want to write row echelon form, if you can. So we'll have z equals 2 because 2z equals 4. So boom, row echelon form with that. Yeah, that's how you get that. So this is called Gaussian elimination, solving our systems of equation via elimination to get row echelon form. And in the next example, we'll go over how to solve the equation or the system once we have our system in row echelon form.